Peter Blaine is the Software Development Manager and Software Architect at the Tasmanian Partnership for Advanced Computing, known as TPAC, at the University of Tasmania. He is the Project Manager for a number of e-research projects at TPAC, including the Marine and Climate Data Discovery and Access Project, macddap. Dr. Blaine received his PhD from the School of Computing and Information Technology at Griffith University in 2007 and a Bachelor of Engineering in Computing Systems from the University of Queensland in 1992. Prior to joining TPAC in 2008, he worked as a freelance software engineer and consultant for large Australian and international financial services companies, including the Bank of Tokyo, HSBC, Westpac, the Commonwealth Bank of Australia and the National Australia Bank, all of which I presume are still running, so that's a good track record. Please welcome Dr. Peter Blaine to present outcomes of the Marine and Climate Data Discovery and Access Project.
I just control the slideshow from that, do I?
Actually, might be easier if you do it here.
That's all right. Okay, macddap, the Marine and Climate Data Discovery and Access Project. This project completed at the end of June this year. It was funded by the National E-Research Architecture Task Force under NCRIS. The objective of the project was to integrate large marine and climate data sets and deliver them through a wide range of data streams, thus engaging a broad community. So in this talk, I'll explain what that means in practice, what our deliverables were, and what the outcomes of the project were. So macddap was a collaboration between TPAC, IMOS, CSIRO, Bureau of Meteorology, and Architecta. And each of these organisations worked on one or more of the 6 main sub-projects that comprise macddap, which are the ones in the big box. There was also a 7th deployment sub-project. So each of these main sub-projects were essentially separate projects in their own right. They complemented each other and interrelated with each other, but they were essentially separate. So in this talk, I will go through and explain each sub-project and the outcomes of each one. So the first of the sub-projects was the enhancements to GeoNetwork. So GeoNetwork is an open source metadata catalogue. It supports features such as metadata entry and search as a web map viewer. It's quite a popular product. It's used at various installations around the world, including IMOS. So IMOS is the Integrated Marine Observing System, which is where I now work. And IMOS is responsible for deploying observing equipment throughout the oceans surrounding Australia, and also for making the data available from those observations available through the IMOS Oceans portal, and I'll give you the URL for that in a moment. So the work that we did on GeoNetwork in macddap was firstly to add automated harvesting of threads catalogues of OGC web services and OGC sensor observation services. And these are all methods of publishing data. So GeoNetwork can now harvest those sources and store the metadata in its repository. And we also improved the searching against these catalogues. We added parameter search, and we also did a lot of work testing and hardening the existing OGC CSW interface. So CSW is an OGC standard catalogue service for the web, and it's basically just a standard for querying catalogues. So here's the URL for the IMOS Ocean portal. And you can also see the URL for the instance of GeoNetwork, which backs the IMOS portal. So basically, GeoNetwork sits behind the IMOS portal. It provides the metadata storage and the search capability. And so the main outcome of the work we did, well, the direct outcome was that the IMOS data is more efficiently available in a more timely fashion through the automated harvesting, and also the search capability is improved. And you'll actually see further improvements through the IMOS portal hopefully at the end of this year or beginning of next year, as we release a new version that takes even greater advantage of the enhancements we made to GeoNetwork. And because GeoNetwork is a popular open source product, there's a broader outcome in the sense that all the enhancements we made are available through the core GeoNetwork to anybody who has an installation. So project number 2. The work here was done on the TPAC digital library. TPAC hosts a large digital library of marine and climate data. It's a very popular place for all scientists to access this kind of data. And sitting in front of the digital library is the TPAC digital library portal. And we made a lot of enhancements to this in macddap. The TPAC digital library portal, by the way, is also an open source product. It's available, and it's a tool for accessing geographic data, heterogeneous, any kind of data available through OpenDAP servers, threads, hierarchs, anything like that. So the first thing we did was we added geospatial and temporal search capability. We also added other search features like a parameter search. We improved the navigation through a file manager style navigation tool, and basically greatly improved the ability to search the data within the digital library. We also did a lot of work improving the performance of the database, which backs the TPAC digital library, and also the web harvester that harvests threads and hierarchs and populates that database. One of the limiting factors we had pre-macddap with the digital library was that really large data sets, so I'm talking in the order of data sets getting up to around 1 million files, were just taking too long to harvest. It was taking perhaps a week or more to harvest these data sets, and we really couldn't publish them. So we did a lot of work improving the performance of the database and the harvester so that we can now publish those kind of data sets. We also redeveloped the whole portal application. It was originally developed in 2005. It's been around for a while, and it had been very popular, but one of the problems we were having was that, well, for example, some of the work we're doing in macddap was very hard to make changes to it. So we redeveloped it using the Spring framework. So Spring is a popular open source lightweight framework for Java development. It supports a lot of enterprise features, including transaction management, security, and lots of others. And as I say, the main advantage for us was that it gave us the ability to be very agile in our development and make lots of changes very rapidly. It also improved our code quality through greater coverage and unit testing. And we also redeveloped the user interface using GWT, which is the Google Web Toolkit. And this is a framework for developing feature-rich user interfaces, AJAX interfaces basically, but allows you to do it in Java. AJAX, as the acronym implies, relies on JavaScript, and so what GWT does is it basically lets you develop your user interface in Java and then cross-compile it into the JavaScript, which is very different from Java, and it handles all the browser differences and idiosyncrasies. So it makes developing a user interface very quick and easy. And both Spring and GWT are available under the Apache 2.0 license, so that they don't affect the open source status of the project. We did some other things. We also added a metadata access and notification service, and what that does is basically allows us to federate separate instances of the TPAC digital library. And that was useful to us because we're working in collaboration with organisations such as the Bureau of Meteorology, and so it allows us to publish data from the Bureau. And we also added a user registration interface and an administrator's monitoring and notification service. And basically these allows data owners to log in, manage their own data, set security restrictions, manage the metadata, set notifications for data management. And we also support AAF as one of the forms through which you can log in, and we also added OAI PMH harvestability and support for the RIFCS metadata standard for ANDs, obviously. So the outcomes of this part of the project, well, first of all, there's the URL for the TPAC digital library. So you can go there and have a look at it. The source code is available on SourceForge. So the primary outcome is that larger data sets and more data sets are now available that weren't previously publishable through the portal. And also the search has improved. As I said, it's got the geospatial, the temporal search, and the much easier navigation through the portal with a much improved interface. Sub-project number 3, aggregation services. So this work was done by CSIRO, who developed the AODAC, which is the Australian Oceans Distributed Active Archive Centre. Edward King just gave a good talk on this. I should have taken some of his slides. They were very good, better than my text. But in any case, the AODAC harvests OpenDAP servers using, interestingly enough, a redeveloped fork of the TPAC digital library harvester that I was just speaking about. And one of the unexpected outcomes of the macddap project was actually the development of this harvester. So if anybody's interested in a good threads harvester, you can get that now from CSIRO. So in any case, back to the AODAC, it harvests metadata from OpenDAP, stores it in a database and makes that queryable to clients, including the AODAC aggregator, which was the focus of macddap. And what the aggregator does is it basically allows a user to specify a geospatial and temporal range, and it will deliver back to the user a single file containing the data from that range. So at the back end, the data might be stored in multiple files, perhaps one file for each time set. So the aggregator will subset those, compile them all together and deliver a 3D chunk of data where the dimensions are X, Y and time, and deliver that as a netcdf or HDF file back to the user. So you can see this in action at the URL on the screen. If you go there, you'll see that there are over 200 data sets available there, and one of the outcomes is the availability of these data sets. And the other outcome is that this technology is going to be used in the IMOS portal for aggregation, and the AODN portal is going to use the same technology as the IMOS portal. In fact, they'll be merged into one, and so the aggregation capability is potentially available there as well. So project number 4, this OpenDAP integration. So macddap was a 3-year project. One of the very first things that we delivered was this, which we did after about possibly just after the first year of the project, I think. And what it was to integrate WMS into Threads. So Threads is a data server for publishing self-described scientific files through a number of servers, including OpenDAP, most notably. But we added WMS. So WMS is an OGC standard. It's the web map service, and it's a standard for publishing spatial images. And in CWMS, which is what we added to Threads, was an implementation of the WMS standard that understands CF-compliant netcdf files. So netcdf files are self-describing scientific files, and CF compliance means they conform to the climate and forecast conventions. So we added this into Threads. So this work was completed about 2 years ago. So now anybody with a Threads installation can enable this feature and start serving up maps of their data. You can see it in action at TPAC at the URL on the screen. So that's good, but again, because this is a very popular open source product, this is available to anybody who has Threads installed. They can enable that feature and start using it. So there's a broader outcome there as well. Sub-project number 5, the OpenDAP enhancements. So this work was done by the Bureau of Meteorology in conjunction with the Hyrax developers from the OpenDAP organisation. And most of this work was around adding security to Hyrax. So we added authentication against OpenDAP requests from harvesters and other programmatic requests. We added trusted communication between the front-end and back-end components of Hyrax, added data management and administrative capabilities for remote management of the server. And the main outcome of this was that data sets that weren't previously available are now available. You can see some of those listed on the right-hand side. These are coming out of the Bureau of Meteorology from their Corker data sets, and these can now be made available. And this is one of the points where the projects start to interrelate, because this is where we're using the metadata and access notification service that I was talking about within the TPAC digital library to republish those through TPAC. And of course, this is another example of development to an open source product. So again, all these features are available to installations of Hyrax. And sub-project number 6. This is the last one. This work was done by Architecture in Melbourne, and the deliverable was to create a web-based application that you could log into and conform threads data to an agreed standard. So, for example, the CF conventions that I was just talking about. And by the way, there's also a command line version as well as being a web application. But here's some screenshots of how the web application component works. You can go to that URL there, and you can actually get a login and use this for yourself. So you log in, you point it at your threads catalog, you give it a conformance level. It will perform a conformance check against that catalog. Then it will come back with a form showing the non-conforming elements, and it will give you the opportunity to go through and augment those. It will prompt you and assist you in filling in those non-compliant elements, and then once you've done that, you can regenerate a augmented threads catalog. You can republish that, and then your data set will be available in conformance, in this case with the CF conventions. So we've been doing this at TPAC, and here are some examples of the data sets that we've been republishing. There's also been interest in using this tool from IMOS and Bureau of Meteorology and others. And that's actually been one of the advantages of, and perhaps unexpected outcomes of the macddap project, was the increased collaboration between the groups that might not otherwise may have occurred. It was actually an interesting project in the fact that there were 6 sub-projects in one. So that was a nice outcome. But the other cool thing, and another place where this starts to interrelate with the other sub-projects, is once these data sets are conformed to the CF conventions, then we can switch on the WMS feature within Threads and start providing visualizations and animations of our data. So, in conclusion, the outcomes of the project were primarily that more data sets are now available. Data sets that weren't previously available can now be accessed. Larger data sets than before are available through the TPAC digital library. All the data is now more easily discoverable through improved search capabilities, and it's accessible in more useful formats through the aggregation services and translation services. If you have any questions about any of this, please feel free to contact me about any of the sub-projects within macddap. There are my contact details. If you have specific questions about the AODAC aggregator, you can also talk to Edward King, who is here at the conference. If you have questions about the OpenDAP enhancements, Tim Pugh from the Bureau of Meteorology, who's also here at the conference. And any questions about the translation services, then Jason Lowry from Architecture is also a good person to speak to, and he's also here at the conference. Thanks.
Thank you very much, Peter. Gift from the committee to say thank you. Any questions for Peter? No, I had one around the, I guess, sustainability. So you talked a lot about using the open standards and the like. As far as organisational responsibility for, because you mentioned further enhancements are still happening, how is that being handled amongst the parties involved in the project?
Okay, so that varies. The question was about sustainability, and it varies from sub-project to sub-project. So, for example, the work we did on threads, that was completed in the first year, and that work has since been adopted by the OpenDAP community, and they've extended it and continued to improve it. So that's a good example of how, by contributing to larger popular open source projects, that the open source community can take those on and sustain them into the future.
Thank you very much, Peter.